and gentlemen, put on your seatbelts. This section is where the rubber hits the road with solving for polynomials. Make sure you take great notes. Make sure you take notes on your notes, and make sure you ask lots of questions, okay? Today, you're going to learn how to find possible rational roots using the rational root theorem. And then from that list, we're going to learn how to find the actual roots from that possible list, okay? So first of all, just a little bit of review vocabulary. If you remember what complex conjugates are, they're conjugates are pairs, and so you always keep the real part of a complex number and then change the imaginary part. And so I'm not going to dive deep into this, but if you recall, if we have a complex conjugate number here of 2 plus I, then its conjugate is going to be 2 minus I. This one will be negative 3 minus 7i, so I'm not changing the real part, only the imaginary part, 6 plus 4i here, okay? And then down below here, these are radical numbers, so these are irrational conjugates, so we have 2 minus the square root of 3, so again, we're not changing the real part, just the radical part. Then we have 1 minus 5 square root of 2, and then negative 3 plus 6 square root of 5. Recall that these are always in pairs, and that's going to be very important tomorrow or on Thursday for Thursday's lesson. Okay? Next thing is you need to make sure you understand number sets really well. Okay? If you recall, our natural numbers are just 1, 2, 3. That's how we learn how to count. Then when we added whole numbers, all we added was 0. We added that whole donut, right? Whole. Then when we decided we wanted to get really sophisticated, we added negative numbers. So our natural numbers plus our donut, our 0, plus our negative numbers. Then we added all of our fractions, and that's when all the wheels fell off, right? So anything that can be written as a ratio, a fraction. So like the number 2 can be written as 8 over 4 or 10 over 5, and so that's a rational number. That's why it is a rational number. Even though it doesn't look like it's a fraction, it can be written as a fraction, okay? So that's a rational number. And it's only decimals that can be written as a fraction also. So, 1.5 would be 3 halves. And so anything that can be written as a fraction or as a rational number, a ratio, okay? Then we get into our whole real number system, and that's anything. That's pi, e, that's kind of crazy numbers, numbers that repeat, square root of 2, just all the kind of the crazy members of your family, right? So that's everything, okay? So you need to know this because when it asks you to find the rational solutions, we're only finding the ones that are can be written as fractions, okay? If it asks you to find all of our complex numbers, that means we're going to get into our imaginary numbers and our complex, crazy rational numbers, okay? And so, be careful when it's asking you to find rational solutions. That doesn't mean you have to find all the complex ones and so forth and so on. If it asks you to find the complex, you need to find all of them, okay? And so make sure you understand that number system. Okay, so we're going to start off here by learning the rational root theorem. This looks like a lot of words. It's kind of overwhelming, and that's okay, so bear with me, okay? This just says if P over Q is a ratio in simple form, and it is a rational root of the polynomial, so it's actually a solution of this polynomial, and this is kind of crazy. This is like a highest degree, so if this was the 7th degree, then this would be 7 minus 1, 6, 5, 4, 3, 2, 1, all the way down to just my number, okay? With integer coefficients, so in other words, these can't have crazy numbers in the coefficients. They all have to be normal numbers. Then P must be a factor of a sub 0. So P, the number on top, has to be a factor of this last number here, okay? And then Q must be a factor of this leading coefficient. So Q has to be a factor of that guy, and P has to be a factor of this guy, okay? And so then once we find all of those factors of P and then factors of Q, we take all the combinations, and that gives us our possible factors of the polynomial. Okay, then we have to find out which ones are the actual ones. So that still kind of seems a little bit overwhelming, so we're going to take a look at what that means. So here we have a polynomial. Well, what are our factors of 32? So it's P over Q. Okay, mind your P's and Q's, right? So all my factors of 32 are going to be 1, 2, 4, 8, 16, and itself 32. We put the plus and minus because a factor of 32 could be a positive factor or a negative factor. So that's why you see all the plus and minus, plus and minus, plus and minus, okay? Factors of 1, of course, are just positive, negative 1. Then we take all the combinations. 1 divided by 1 is 1, 2 divided by 1 is 2, and so forth. So these are all of our possible roots right here. 1, 2, 4, 8, 16, and 32. all positive and negative. So we have what? 1, 2, 3, 4, 5, 6. So 12 possible solutions, right? Because it's positive and negative. And then we have to find out which one of those are our actual roots at some point, okay? But these at least give us an idea. Otherwise, we're just shooting in the dark of which roots we have, okay? So what about this one here? Here we have a polynomial. Here's my factors of 6, 1, 2, 3, and 6, and of course, all positive and negative. Here's my factors of 2, positive and negative. It goes P over Q, okay? So then I take all my combinations, 1 over 1, 2 over 1, 3 over 1, 6 over 1, and then 1 over 2, 2 over 2, 3 over 2, and 6 over 2, and then I simplify all those. And of course, I don't want to repeat any. 1 over 1 is 1, 1 half, 2. 2 over 2 is also 1, so we're just going to write that one time. 3 over 1 is 3, 3 halves, 6, and then 6 over 2 is also 3, so we don't want to repeat that. So here's all of my possible roots right here. All of my possible roots are right here. And then I just have to find out which ones are actual roots at some point, okay? So we're going to practice, finding our actual roots, or our possible roots, excuse me. So my P, in this case, is 8, okay? So all of my possible factors of P are going to be positive and negative 1, positive, negative 2, positive, negative 4, and positive and negative 8, okay? And then we're going to look and see what are my possible factors of my Q. In this case, it's just 1. And that's usually pretty easy because, and sometimes you don't even have to list your positive, negative 1 because anything divided by 1 is just itself. And so a lot of times you'll find if there's a coefficient of 1 out here, we don't even need to really list that. But we'll do it for now just because we'll do it, okay? So these are my possible roots. Okay, we're going to find the combination. So 1 over 1 is going to be positive, negative 1. 2 over 1 is going to be positive, negative 2. 4 over 1 is going to be positive, negative 4. And 8 over 1 is going to be positive, negative 8. And those are all our possible roots. And so this is the first step, is just listing out my possible roots, okay? Once we find our possible roots, then we're going to take the next step and find out, which ones are the actual roots, okay? So here's a little bit different one. Now we actually have a coefficient out here in front. So we have a P over here and a Q over here. So let's find our factors of P. So our factors of 27 are going to be positive, negative 1, of course, positive and negative 3, positive and negative 9, positive, negative 27. I think I got them all, right? And then that's going to be all over my factors of Q, which is going to be 9, right? Positive and negative 1, positive, negative 3, positive and negative 9. Okay, and I want to go ahead and circle this up here to make sure that we know that's my factors of 27. Okay, so now all my possible roots are going to be, I'm going to go ahead and get a different color here. So 1 over 1, so positive, negative 1. 1 over 3, positive, negative 1/3. 1 over 9, positive, negative 1/9, right? So now let's go ahead and get some, I'll just move the red here. So 3 over 1 is going to be positive, negative 3. 3 over 3 is positive, negative 1. We already have that, so I'm going to leave that, okay? Then I'm going to go to 3 over 9 is positive, negative 1/3, and we actually already have that as well, okay? Now I'm going to go ahead and do my 9. 9 over 1 is positive, negative 9. 9 over 3 is positive, negative 3. We already have that. And 9 over 9 is positive, negative 1. We already have that one. Okay, let's go ahead and move to, what color don't we have yet? 27 over 1 is positive, negative 27. 27 over 3 is positive, negative 9. And 27 over 9 is positive, negative 3. So these are all my possible rational roots right here for this particular equation. And then we just have to find out which ones are actual roots. Okay. Okay, so you try it. I would suggest, pausing this video and trying to list all the roots and then come back and check and see how you did. All right, so all of my possible roots here are going to be factors of 12. So it's going to be positive, negative 1, positive, negative 2, positive, negative 3, positive, negative 4, positive, negative 6, and positive, negative 12. All over, we got positive and negative 1, right? And since everything is just positive and divided by 1, we can just list them out as positive, -1, positive, -2, positive and -3, positive, -4, positive, -6, and positive, -12. And those are all of my possible rational roots for that one. Okay, we're going to try one more before we move on. And go ahead and pause this and see how you do with this one, because this one has a coefficient. Okay. Okay, so coming back, we have factors of 6, which are going to be positive and -1, positive and -2, positive and -3, and positive and -6. And that will be all divided over positive and -2. So positive and -1, I should say factors of positive and factors of 2. Okay, so then my actual roots, my possible roots are going to be positive and -1 over 1, 2 over 1, 3 over 1, and 6 over 1. And then we're going to go to 1 over 2, so positive -1/2. 2 over 2, which is going to be positive -1 again. 3 over 2 is going to be positive -3/2. And then 6 over 2 would be positive -3, which we already have. So these are my possible roots right here. Okay? All right, so that's the first step. You need to make sure you understand and know how to find our possible roots before we even move on. Okay? So the next thing we're just going to kind of review is if we have this graph here, it looks like it goes through 4. Maybe it's 4, maybe it's not. How do we tell if it is? Well, if you recall, without substituting, we can always plug it in here, but without substituting, how can we determine that P of x equals 0? Well, if you remember the remainder theorem, if we actually divide 4 into this whole gobbledygook, 8, -32, we don't have a third, so we're going to have to put a 0 there, 1 and -4. If we have a remainder of 0, that will tell us whether or not that is actually 0. So I'll bring down 8. 4 times 8 is 32. That's 0. 4 times 0 is 0. That's 0. 4 times 0 is 0. That's 1. 4 times 1 is 4, and that's 0. And so because this has a remainder of 0, that means that 4 is indeed a 0. Okay? So we're going to use this division method to test our zeros. Like we have those possible zeros, right? But we're going to test and see which one is actually a 0 by telling which one is going to give us a remainder of 0. Okay? So now that we have all that under our belts, we know how to find possible roots. We know how to use division to see if it's an actual root. And so we're going to now start doing this. So remember, first of all, when we solve, always see if you can factor first. Do we have quadratic form here, which we do not? Can we factor by grouping here? We cannot, because there's nothing that will end up looking like. So then this is kind of our kind of last resort. Okay, so I'm going to write down my possible rational roots. Since this is a coefficient of 1, I'm just going to write down my factors of 10. So positive and -1, positive -2, positive and -5, and positive -10. Okay, so those are my possible roots. And how we find out if they're actual roots is we test them, just like we did before. We divide and see if it gives us a remainder of 0. So that's where we start off with. Okay, so I'm going to start by going with positive 1. And I divide it into 1, 2, -13, and 10. And see what happens. So I'll bring down this 1. 1 times 1 is 1. And add these guys, which is 3. 1 times 3 is 3. Add these guys is -10. 1 times -10 is -10. And would you look at that? We have a 0 right off the bat. Because this gives me a remainder of 0. That means that this 1 is indeed a 0, and that makes us very happy. So this actually we know is a factor. It's a 0. So we write that as x minus 1, right? This stuff right here, we can rewrite, if you remember from last week in division, as a quotient of x squared plus 3x minus 10, okay, equals 0. So now this is the same thing as that, just in factored form. If you recall from last week, we can write this as a quotient of my divisor times my quotient here, okay? So now what we can do is we can take this guy right here. This is just a quadratic function, x squared plus 3x minus 10. And we can solve for that, and that's factorable, okay? So this guy, we're going to continue to factor. What are factors of negative 10 that add up to positive 3? And we know that's going to be a 5 and a negative 2, okay? So we factor that into x plus 5 times x minus 2. And then, of course, we're going to keep this factor because that's all part of it, x minus 1. Whoops, I forgot my 1. Here we go. And that's all equal to 0. Okay? Now we have this entire polynomial in factored form. This time it's this one times this one times this one equals 0. So I can identify my zeros now. My x is going to be equal to a positive 1, a negative 5, and a positive 2. And there's all my zeros. Now I can actually graph it. There's all my zeros. I know it goes up on the right-hand side because of my leading coefficient. My left-hand side does the opposite thing. And I can kind of sketch my graph if I wanted to. Okay? So those are all my zeros. And that's how you solve a polynomial function. Those are my rational solutions. Notice, please, that the number of zeros I have matches my power. I have 3 solutions and my power is 3. That's very important to kind of pay attention to as we move forward, okay? Okay, so for this one, we have a coefficient this time, right? So we're going to need to look at our factors of negative 3 right here, which is going to be positive and negative 1, positive and negative 3, all over right here. And we're going to look at our factors of 2. So positive and negative 1, positive and negative 2. That's going to leave us with our combinations are going to be positive and negative 1, positive and negative 3, and then positive and negative 1/2, and then positive and negative 3/2. And then we'll start dividing. So I'll divide by 1. You have 2, 3, negative 2, negative 3. Drop down our 2. So 1 times 2 is 2. Add those is 5. 1 times 5 is 5. That becomes 3. 1 times 3 is 3. And that gives us a 0 right away. So that's beautiful. Okay. So this becomes our 0 right here. So that becomes x minus 1 is our factor. And then we have all this nice leftover right here, which is going to become 2x squared plus 5x plus 3 equals 0. Okay. And so now we're going to have to find factors here. So what are factors of 6? They're going to add up to 5. Okay, in this case, it's going to be 2 and 3. So that will be 2x squared plus 2x plus 3x plus 3, if you remember how to factor. Okay, I'm going to go ahead and group these guys. So factor this out is going to be 2x. And we'll be left with x plus 1. And I'm going to factor out a 3, which will be x plus 1. Okay. And then that will leave me with my x plus 1 times my 2x plus 3. And then, of course, don't forget my x plus 1. Bring that down here. Right. Keep him engaged. And all that is equal to 0. Okay. So I'm going to bring this guy up here. So we have x plus 1 times x plus 1. So notice that there we have 2x plus 3 equals 0. So this is actually a multiplicity here. That can be written as x plus 1 squared and then 2x plus 3. Okay. So we have x equals a negative 1. Oh, sorry. Rewrite that there. Sometimes my pen doesn't work very good. We have a negative 1, and that is a multiplicity of 2. So that occurs twice, right? For multiplicity of 2. And then we have also x equals negative 3/2. And again, if you're not sure where I came up with the 3/2, that is from, okay, down here, 2x plus 3. When does that equal 0? We just have to solve for that. 2x equals negative 3 and divide by 2, which gives us our x equals negative 3/2. Okay. So those are our 2 zeros. So even though it looks like we only have 2 zeros, we actually have 3. We have 2 negative 1s. That's why it bounces right there. We have one that's a negative 3/2, and that's how we end up getting our 3 zeros. Okay? pause this and work through this and see if you can, how you do on this and come back, okay? So you can kind of see what I did and what you did, okay? Okay, so my possible roots are going to be positive and negative 1, positive and negative 2. That's my factors of 2. And then we'll take my factors of 3 over this. So positive and negative 1, positive and negative 3. That's going to give us possible roots of positive and negative 1, positive and negative 2, positive and negative, 2, 1/3, and then positive and negative 2/3. Okay, so these are my possible roots right here. So you start dividing. I'm going to start dividing by 1 and see where we go from there. So I go 1, whoops, I need a pen. There we go. 1. And I'll have 3, negative 4, negative 5, positive 2, excuse me. So bring down the 3. 1 times 3 is 3. That brings me negative 1. 1 times negative 1 is negative 1. That gives me negative 6. And so this one is not a 0. So we're going to try negative 1. 3, negative 4, negative 5, and 2. Bring down my 3. Negative 1 times 3 gives me negative 3. That gives me negative 7. Negative 1 times negative 7 is a positive 7. That gives me a positive 2. Negative 1 times 2 is a negative 2, and we have a 0. We always love it when we have a 0, right? So that is going to be a factor of x plus 1, since it's negative. And that means the rest of these guys here is going to be 3x squared minus 7x plus 2. Okay, so this is that in factored form. So now we have a quadratic here. So how do we do this? We're going to try to factor this. So we're going to 3 times 2. So I'm going to go ahead and bring this up here. So I have my x plus 1 times 3x squared minus 7x plus 2. Okay, so we need to take this guy and factor it. So if you recall, we take 3 times 2, which is 6. Factors of 6 add up to negative 7. In that case, it'll be negative 6, negative 1. Okay, and so we're going to take this and go 3x squared minus 6x minus 1x plus 2. And we're going to factor those. Okay, we got to recall how to factor these. That's why I told you you cannot forget how to factor. I'm going to change this to a plus and negative so I don't lose that negative in here. Okay, I'm going to factor out a 3 and x here, leaving me with an x minus 2. I'm going to factor out a negative 1 right here, because negative 1x divided by negative 1 is a positive x, and 2 divided by negative 1 is a minus 2. So I have these x minus 2 as the same factors. So this will be x minus 1, or excuse me, x minus 2. And then I have left over my 3x minus 1. Okay, and now don't forget my x plus 1, of course. Keep that down here, x plus 1. And we have all of my factors. Okay, so x is going to be equal to negative 1, positive 2, and 1/3. Now, if you're not always sure how I got the 1/3, it's because 3x minus 1 equals 0. I add 1. 3x equals 1. Gosh, I can't draw very good on this. Divide by 3, and x equals 1/3. That's how I got the 1/3 there. So here's all my solutions, all my rational roots. Okay, that is how you start to find all of our rational roots. Okay, you have a worksheet in Google Classroom. You first start by identifying rational roots only, not solving, and then that's the first 2. And then the next 6 will be solving. Watch out, because some of them use quadratic factoring, like quadratic form, and factor by grouping, and that was a lot easier if you do it that way. You continue, solving, and so make sure you pay attention to that. Okay, so have a great time. If you have any questions, please bring them to Zoom and or email me, and I'll talk to you later. Okay, thank you. Bye bye.